Okay, so thanks everyone to join. I'm Riccardo Susini. I'm the person that starting 2018 coordinate our distributor network in Med region in EMEA. So as you know, and I start in 2018 moving the coverage of some area and so on to our partner, where probably you have already been in contact with. And today I want to wrap up, which is the latest status of NI in terms of company and which is our strategy from hardware and software. Okay, as you probably know, NI became part of Emerson Group. So now we are in a very huge company that is like more than 13 billion yearly turnover. So we stay in T&M science more than 45 years. We have 35,000 customers everywhere in the world. We started to be organized in business units, so we try to be organized in this way. So we have a specific focus for electronics, semiconductor, aerospace, defense, transportation, and manufacturing, energy, and so on. So we are divided in these 4 application areas. And finally, we provide a solution thanks to the collaboration with our partner network in design and prototyping, validation, and production test. So we are mainly focused in the test part. Which is our vision? Our vision is leading the future of test automation. So we are working to provide continuous improvement to our platform to be able to increase the capability to make automated tests, both in different application areas. You know, aerospace and defense is one of the pillars of NI, generally speaking, but we have made a huge investment in transportation. We have acquired companies to help us to grow our platform for EV market. And we have even increased our presence in the semiconductor area. We have developed a complete test to make semiconductor and electronic production validation and so on. So we are mainly focused to remain leader in the test automation. But generally speaking, these are the main areas where we want to be present close to our customers. So laboratories where we know we have a very wide platform solution that helps to make different types of measurement. We are increasing our capability to make structural measurement with distributed I/O and very accurate and rugged solution. We are increasing our solution for all the thermal and electrical measurement, NVH test, all the part in acoustic, thanks even to the collaboration with our partner, like MeasureIT. They provide even microphone and all the stuff to make acoustic measurement. We already discussed about power, and we are even working to improve the solution for endurance and product life cycle test. Finally, we are developing a new platform to make functional software to be able to collect multiple data and analyzing these multiple data to create a data mining application that can help you to take decision coming from your test. Then I will go in the details and I will show which could be the right solution we want to offer. So right now, let's stay focused on the hardware part. Then I will skip on the software. So on the hardware part, we remain on these, I would say 4, but in reality, we are merging CompactDAQ and CompactRIO step by step. So I would say 3 platforms. One is the PC-based system, generally speaking, data acquisition, but not only, where we have released our latest product that probably you have heard because we did a little bit of noise on the marketing side. That is MeasureIT. MeasureIT is a revolutionary USB power DAQ solution with a rack mounting that can help you to decrease the cost for data acquisition and improve quality and simplify the adoption. Then MeasureIT will present you the product in a more efficient way. Then we still, sorry. As I say, the CompactDAQ and CompactRIO for rugged, cost-effective measurement, a distributed measurement that can be used for data acquisition or control. You know that this is one of the area where we have grown a lot in the latest 15 years. Sorry, there is a time. The last 15 years for facilitating our measurement in the industrial application. And finally, PXI. PXI is mainly for high-end solution for test and validation. Let's go in details in CompactDAQ and CompactRIO. We have more than 70 modules, and we have the capability to extend this and synchronize over Ethernet multiple chassis. So it's a very performing platform to make a heavy distributed I/O test solution. It's very rugged. We have options that can arrive up to minus 40, 70 degrees Celsius running. So very important for application where we need to have immunity from thermal and electromechanical situation that can disturb your system. And we are, on top of this platform, we are creating multiple different driver approach. So right now you can use our solution with the new data logger system we have that is called FlexLogger, or we can move to a different subset of drivers. So we have LabVIEW, or you can program in Python, .NET, or C++. About the software, I would say that we have complete all the integration of Python in all our hardware solutions. So right now, if you want, you can use a Python solution to address all our target application. Which is the benefit of CompactRIO and CompactDAQ? It's very integrated platform. So thanks to LabVIEW, you can reduce time development. You can make, as I said, heavy synchronized measurement, very rugged solution, and it's very accurate. So compared to the standard you can find on the market related to distributed I/O, our modules are very accurate, and you can calibrate the modules if you want. So we are able to make measurements that are really more performing that you can generally find in the automation market. This is still one of our pillars. Then, if you want to go in the details, we have worked to increase in the embedded version the security of our solution to don't let external address that can create problems to the security of our application. And as you know, thanks to the FPGA approach, we can guarantee a very high-speed deterministic control to all your application. This is one of the key points that differentiate CompactRIO versus the standard you find on the market, the capability to address the FPGA. Okay, moving to the PXI. PXI is a different solution. You know that it's more for test, but you can even use for control, especially for HIL, where you need a very powerful CPU. In PXI, you have a high bandwidth, so you can make record and playback coming from high bandwidth instrument like digitizer or RF or millimeter wave solution. We can arrive till 12 gigabytes per second managed by a single CPU on PXI. So it means that it's a very wideband system that can help you to address the more challenging application. But again, it's a very, it can host multiple type of instruments. So not only high bandwidth, high speed instrument, but the standard DAQ or sensor-based solution, for example, for sound, vibration, and bridge and strain. So generally, PXI is one of the reference architecture for turbines, for example. So companies that make turbines, they need a very important high bandwidth channel for sound, vibration, and so on. They refer to PXI because PXI can arrive up to 300 channel for acoustic, more than 100 kilohertz bandwidth. So it's a very, very important platform that can be scaled at the different level. Here you can see a short summary of the key feature of PXI. So we start from the software part that can be used at different level. Right now we have focused to develop ready-to-run application that is called Instrument Studio. So they let you not to make any program, but use as a box instrument if you want, or otherwise you can develop your application. All the instruments are timing and synchronized, and you can host an embedded PC in the system. The embedded PC will help you to have the maximum performance, and you can target with Windows OS or a real-time application, according if you want to do, for example, control, HIL, or if you need only to have a test system to make acquisition, and so on. Here you can see the instrument set. It's very wide, starting from the multifunction I/O. We arrived till the signal generator, DMM, and SMUs, the switching part, and the RF analyzer. On RF, we have developed a very performing solution that is called VST that help you to make RF measurement in a very cost-effective way compared to the benchtop solution. VST means a vector signal transceiver, so help you to have a generator and an acquisition in RF at a quite interesting cost factor. Okay, moving to the software part, that, as I said, it's one of the most important for us because we still want to be a software-centric company. We have 3 levels of software that you can adopt in our solution. As I said, we have developed a completely new data logger that is called FlexLogger, and I suggest everyone to download FlexLogger and try to use it and see how it works, because this is one of the points that I didn't have in the past, a very performing data logger, and now we want to address this part of software, so facilitating those customers that doesn't need specific customization, but they want only to make acquisition in an easy way. Then, as you know, we have a specific tool to make a test. So Test&Measurement is our reference software to make application test solution. So it helps to create a scheduling for making tests and so on. And then we have a series of programming environments that we want to adopt with our software. Still, we are focusing LabVIEW because we believe that LabVIEW can be the right software for all the measurement and test application. But we are opening, as I said, to Python, and okay, C++ was already one of the software we integrate. So we have complete all the integration with Python. Then, as I said, we are strongly investing to facilitate the acquisition of data from multiple test systems, thanks to a system link solution. System link is a new software that helps you to collect data from different test benches and be able to make a report and update the firmware of each test benches, make remote analysis, and so on. And all the Diadem and Optimal Plus solution that helps you to keep all this amount of data that arrive from your test system, create automatic report, create a query to find out specific situation that happens in your test solution in the previous test unit versus the actual one. So thanks to Diadem and System Link, you can easily collect the data and analyze the data that are arriving. Okay, so moving to the software part, I want to highlight which is our vision. So the vision is that, okay, LabVIEW remains centric in the application, but we want to facilitate the connection between LabVIEW and all the other tools that we have. So Instrument Studio, Test&Measurement, we already discussed. Verisstand is our software for the HIL. So we want to work to facilitate the connection workflow, and we have even created a solution for that is called LabVIEW Plus Suite. We want to deliver new capability to NI software. As you know, LabVIEW was developed in a certain period in a new version that was LabVIEW Next Gen, and then we stopped LabVIEW Next Gen. We keep all the update of LabVIEW Next Gen. We try to re-actualize the actual LabVIEW with those updates. So we have now the zoom, we have the user interface, and so on. And finally, we want to re-engage with our community. So we are relaunching some initiative, for example, the LabVIEW user group meeting and so on, that want to re-engage the community of LabVIEW and start to be focused again in the development of LabVIEW. Here you can see which are the strength software we are working in. So accelerate the development, improve product and process. Now I will show you some news about artificial intelligence. But finally, I would say that we are quite focused to add different topics and the feature to LabVIEW that can help you to increase the productivity. This is the solution I discussed you. So we released a LabVIEW Plus that is a comprehensive suite of software that help you to facilitate the interconnection between the acquisition, the analysis, and the presentation of the data. So I suggest you to see which could be the proposal for LabVIEW Plus because it's a very cost-effective solution. Finally, for a very, very small price more, we include all the product on that part. And this is all the activity that we want to do with our community. So facilitate event like user group, increase our transparency with the roadmap collaboration, more option and training for education, and so on. So this is the area where we want to be focused on. About LabVIEW roadmap, here I try to summarize which are the features that we want to focus on LabVIEW improvement. So as you can see, we have a quite interesting roadmap to add different types of functionalities, both in 2024 and 2025. We are going to support a different new feature. And again, we want to facilitate the feedback received by the community and create a roadmap on LabVIEW for the next years that will help to bring what the environment needs to our community, finally. Okay, here is a quite detailed list about which are the investment teams related to the roadmap I show you finally. So as I said, we receive this feedback by the community. Our R&D has already mapped some gaps. We want to have to collaborate with you, finalizing the best product for the future. So finally, the message is that after 3 years where we moved to LabVIEW Next Gen and then we stopped the project, we keep back some news coming from this environment. Now we are deeply investing in LabVIEW. We want to continue the improvement of LabVIEW to help you to facilitate the development. So this is one of the new tools that we are releasing. Now is a beta version, but you can download a link, get the access, and be part of the community. Is the LabVIEW artificial intelligence module that can help you to make some easy steps in LabVIEW. So first of all, okay, this is the QR code. Then I have even in the last slide to request the access and to make development. So where it can help, for example, there are in case I will start a new application, I need a few time. It can generate a VI. So you can go to Tools, select an IGL VI generator, make the login. Then you can address the question, like I want to create a software that can make measurement between 0, 5 volts and so on with a certain sampling rate and so on. So like a ChatGPT. So you make a question, you have to well detail the question you have to do to the tool. And the tool reply with an application software that is already developed for you. In the source code, you can keep the source code, you can make all the modifications that you want. And this is a first part. I remove a second part because it's still ongoing, but it's a step-by-step support in development. So while you are developing the software, you can activate this feature and it proposes you some suggestion to move forward in a well-developed application. So this is something that you can even have access to the tool. Okay, maybe you can even not like that it helps you to build the code. It's true, it's correct, can be correct. But think about that, for example, the artificial intelligence can be very useful in finding the right example. So for example, you can go to the artificial intelligence, again, same step. You can ask to find out a specific example to make specific measurement, for example, strain measurement, quarter bridge with the calibration and so on. And you can go in all the repository we have. We have a different repository in the community internal, and you can find out which is the right example that can fit your application. And this is, for my opinion, another very useful example how to save time thanks to artificial intelligence. Last but not least, documentation. I'm quite sure that the 80% of you make code, but make very few documentation, probably, because it's time consuming. It's okay. Even if you do core one, the second hour, they start to say how you have to properly document your VI and your application to let other developers to go inside and to manage better the project. Again, you can go in the code that you have developed and you can ask the artificial intelligence to add the documentation of the VI. And automatically, it can go in the VI panel, it creates a short documentation, and it can even help you to create the extended help of your VI. So these are three areas where I believe artificial intelligence can really help. Okay, so I have concluded. This is the QR code if you want to start downloading a work in the beta version of our tool. And I let my colleague to have a more dedicated session on HIL and power electronics. Thank you.
Can I take
Yep.
Thank you very much.
Oh, perfect. No? Perfect. I have more time. Perfect, yes, to be. Thank you.
You can already start. I believe it will be added as a product in 2026. Yes, as a product. So right now it's a beta version, and you can use it. It's for free, so finally there is no charge to use it. And we want to collect feedback, improve the functionalities, let it to be more reliable, and probably I think that 2026 it will be potentially will be released.
Is it working now? Working now, Guillermo? Yeah, sure. Yeah, good. Okay, we go back. So really what they want is to leverage the data that we are all producing with our test systems and solutions to reduce time to market. They need to release products faster, and I think everybody's struggling with releasing products, right? Or either they release products that are not ready, or they don't release because they never get ready. There's obviously a race to reduce cost. And we see that a lot of companies, although they are profiting, they're still cutting jobs and reducing workforce because the race for profit is really tough right now. And they need to be ready for what the future will come and bring to the table. I mean, nobody knows how ADAS computers will be in like 1, 2, 3, 5, 10 years from now. If you're not ready, you're going to be behind. And that's a major problem. So automotive leaders have been pushing for this for a while, and we believe we can help. How can we help? Come on. Oh, you went through. Oh, perfect. No, I don't think the arrows are working. No. So what we believe we bring to the table is a unique way to get data insights. Fully connected platform from ground up, as Ricardo presented, down to your data acquisition, automation, data storage, data management, and all the analytics you need to run on your data, model-based analysis or AI-based analysis that you can use on top of this data to really make decisions and drive your business to be more profitable, to release products faster, and to be more successful. With the fact that we can actually connect all these layers in software, we believe this is a huge differentiator. You don't have to lose a lot of time in connecting the tool that is here to the tool that does this, to the tool that does that. They're all connected already. All you need to do is use them. And if we don't have the right tool, plugging in a new tool is simple. All things that we have are open, as Ricardo said, fully integrated with Python, for example, and many other programming languages. So you have access to plug in your tool, rather a tool that you buy in the market or a tool you develop in this workflow and use it freely. How do we go about that in like the software challenge that I just mentioned in automotive? Everybody's now saying, we have like software-defined vehicles, right? Or SDV. So that's the new lingo for automotive. Software-defined vehicle, software-defined vehicle. What is that? It is a bunch of different things all combined together. But in a nutshell, there is a lot more software in each of the cars. The cars are getting more complex. More cars with ADAS and EV or hybrid functionality are being released. So the software complexity is scaling. And now, like very different than it was before, your car gets updated overnight. How many of you have had that experience? You wake up in the morning. I had that a few months ago. I turn on my car and the screen is completely different. What just happened? I mean, it was not like that last night. Oh, now it's like this. Oh, cool, I didn't know. Now I have to learn how to reuse my screen because I don't know where the buttons are. Which is fine. It's very weird. Once you learn, it's like, oh, there's a bunch of new cool things. That's nice, but it's kind of weird. And I feel like, am I testing this or was this tested before it was given to me? I'm not, like, I don't feel good sometimes. But then you have to see what the automotive industry is doing in the back. I mean, the investment that they are putting in software is gigantic. Close to half of all the R&D money in the world of automotive goes to software. So it's a major shift. This was probably 15% before. So it tripled, and it will grow. That's where the money will be spent. That's where they see value being added to the customers. Well, that brings challenges. You have a massive piece of software that is designed here, that is tested in prototyping phases, gets deployed to an ECU, and now this thing is a beast. It has a lot of different functionalities inside the same ECU. I'll show in a couple minutes. And you have to test it. But to test it, you pretty much have to fake the real world for the ECU. So it really believes it's in the car, being driven around. And that's what HIL is. So you do, it's called hardware in the loop. You simulate the world around the ECU, everything. If there are cameras, you simulate the images the cameras would get. If there is a LiDAR, you simulate the LiDAR. If there is a motor, you simulate the motor. And the inverter, sometimes, if this ECU doesn't have the inverter inside. All in PXI. And you test the software, the embedded software of this ECU in a closed loop. So this has scaled to the roof, to the point that now Amazon, AWS, is deploying HIL systems in the cloud. And you can deploy your test in the cloud at Amazon. You ship them your ECU, they hook the cable, and now you deploy your test system in the cloud and you test it in their cloud. Because the volume scaled to the roof. It got more complex and much bigger. You finally do some physical testing at the end. You always do that. There's no way to escape that. You might reduce that, but you will never stop doing this. Because a lot of the data that comes from physical testing helps you improve the models that are here. So you get real data from here and improve your simulation. Test more physically, get more real data, improve your simulation. So this gets better. Okay? So it's important to have physical tests as well. Well, why are the cars getting more complex to test, the embedded software getting more complex? Before, each domain of the car had their own little world. So body and chassis, so everything that controls like your comfort, the seats, air conditioning, and some of the chassis functions were all combined in a single little world or domain, and they were contained here. And then you had connectivity in another one and whatever else, right? And you had a gateway to communicate across. That changed, like combined into single big controllers, like domain controllers. So you had a large ECU taking care of a full domain. But that evolved quickly to zonal controllers. So basically you have ECUs located, think about located in the corners of the car, but actually the functionality in each ECU is a combination of everything that piece of the car needs. So you might have brake, powertrain, ADAS, comfort, infotainment, all in the same computer. Before you had one domain running in a computer. Now you may have 6. So the software got a lot more complex. And there is a lot more data that goes back and forth now. Because a control software that is running here might need data generated here, here, and here to close the loop and control the brake of your right back tire wheel. So software got a lot more complicated. And testing it, therefore, got a lot more complicated. And we don't have a way out. We have to test. So how do we do that? First, you're going to need to be able to test everything. So companies that used to be specialized, oh, I'm the best in powertrain HIL testing, well, that's no longer an advantage. Because there's no powertrain ECU anymore. It's gone. It doesn't do only powertrain. You might still have an ECU that's predominantly doing powertrain, but it doesn't do that only anymore. There are other things in there. So you have to have a bunch of new things connected in your HIL system. And you have to be able to start at the desk of the engineer developing software, testing a little thing, really, I would say more R&D type test than really a V&V, verification validation. And then you go down to a component, you go down to a subsystem, like a subset of your full car. And system integration, like the full vehicle integration testing, became as important as ever. This is something that 10, 15 years ago, you would rarely see in automotive. This is something you would have seen in aerospace since like the 70s or early 80s. But in automotive, this was very rare. Now, this is de facto standard in automotive. You have to do that. Because it's very difficult to validate some of these ECUs just alone. You need the others so you complete the system. Well, systems got a lot larger. They get a lot more expensive. You're talking dozens of IOs, maybe 100 IOs, maybe a few hundred IOs to thousands of IOs. So this is few thousand, maybe a few dozen $1,000 or euros. This is like $1 million or more of euros. It's a lot more complex. One of the things that we realized when getting more and more into these labs, when we would ask how the existing labs work, I'll ask you a question, see if you want to guess. When you walk into an HIL lab, anywhere, I challenge you if you do it in your own company, just pick a rack and say, that one. What is the percentage of the time that rack is being used for test? You want to guess? Real usage. 30%. $2 million sitting there 70% of the time idle. That's a lot of money to be sitting there and collecting dust. You can't afford that. So one of the areas that we work the hardest with customers is to enable them to actually use this as much as possible. One of the struggles that people have is that the car infrastructure and the architecture changes a lot during the development. So you have an HIL system, you connect the ECU, you start testing, the ECU changes. Now you have different pins, you have different I/O. What do you do now? My system is not ready. You open it, you start recabling. I have a customer in Brazil that tells me the following. Every time I send a technician to fix cables inside a rack, he fixes one and breaks three. Because the racks are not designed to be tweaked like that. You don't design them for that. So the poor guy or girl has to go there and figure it out. Right? I need to find space for this wire to go down. It was not designed to go down. What do I do now? It's just miserable. Well, we decided to fix that with a different approach. First, there's a lot we do in software, and I'll show that in a couple slides. Second, we have I/O breadth wider than anybody else because of two facts. First, we have a very broad platform ourselves with PXI and C-Series, CompactDAQ, CompactRIO. Third, because we actually trust in the community. None of our hardware platforms are closed. PXI is an open standard, and it has been since the release in 1997. We have Pickering here, one of the biggest manufacturers of PXI modules. The whole community builds modules, and they all work together. So when I build about, 1,200 different types of PXI modules, there's probably 3,000 different types of modules out there. So you can use them all. So you're never going to lack an I/O. Oh, I need this weird thing. I guarantee you, somebody has a PXI module that has the weird thing. Somebody has gone through that. Or in C-Series, or in another platform that I will talk about, which is SLSE. We allow customization from the ground up in the way we design products and solutions. So when customers have to change the system on the field, it's easy to do that, right? And we are open to integrate with any piece of software and any piece of hardware that the other party allows to. Every now and then, customers ask me, why can't you integrate with that? We can't because that does not allow. We do. But the other thing has to allow it. We can hack ourselves into that, but if they change it, the integration will break. So that's not worthy. What does a system look like inside? As I mentioned, we're going to use PXI for all that Ricardo said, all the I/O, real-time processing, etc. and all. But Automotive has a bunch of I/Os that you typically don't find in PXI, or are very hard to develop in a single PXI module, because you need bigger components. It's hard to fit everything. PXI is very compact. For that, about a decade ago, and I decided to develop a hardware version of the App Store. We call that SLSE. This was designed so anybody could put hardware in a platform that is open. It's very easy to design hardware. We have design guides that you can just get from NI for free. We have empty modules that you can just put your electronics inside. The drivers are implemented. You just snap it in the chassis and it works. Okay? NI has actually about 6 modules for this. And there are about 200 modules out there. So we developed very few because we made this for the community. And these two things together form the solution that we see benefits the community for designing these systems. One of these partners that we have that developed this is called Aliaro. and they build HIL systems based in our technology, and they take our SLSC and put inside of their product, which is this little unit here. It's called XMove, which basically removes that and makes it pretty like that. Thousands of wires, 10 cables, maybe 20. What if I need to change a pin? You change that in software, no problem. You go into the software and say, this pin here, there was an analog input. Now I need it to be a digital output. In software, you go there, boom, done. No recabling. You never will open the rack again, unless you need more I/O. You don't need to change any pins whatsoever anymore. That moves the utilization rate of your rack to the roof, because configuring this is like a matter of seconds. That can be actually part of your software. I know I'm testing ECU 1 to 3. For that, the pin out is the following: configure the hardware, run. Done. And that's it. We got an RFQ the other day. The customer says, I need the HIL system to be reconfigured in 24 hours. We're like, okay, we will have 23 hours, 59 minutes to spare. Because we need maybe a minute to do it, because it's software-based. It's not hardware-based anymore. Let's keep that. So if you look at the whole solution from the ground up, we provide a bunch of the green, but we trust the community to bring a lot of the other colors. With our partners developing technology, product partners, integration partners, our distributors helping to bring the technology to your doors and supporting you in the local markets. And with I really listening to the customers and trying to bring that feedback back home and push products that are more aligned with what you need to do. There is a nice case study that I will leave in the slides, because I know Guillermo will share the slides with you. If you want to take an action item from me, scan that. That's a very nice video explaining how this whole thing works. And this concept can be used for anything. It's not only for HIL. If you have a test bench that does other things, and you need to reconfigure that test bench often, that solution is quite interesting for that. And it can be acquired from NI or from partners or from our distributors. So there's a nice, cool video there that you can leverage and use for these applications. Okay. Guillermo, 10:10, is that it? What I have, or 10:05? Oh, I have 7 minutes. Oh, I have time. I can do a lot in 7 minutes. Let me do 2 slides on EV, so we see what we do. One of the areas that I invested the most as well in the past few years was battery testing. There's obviously a lot of focus in testing batteries, despite the market crashing a little bit now. Let's just think about this. The Chinese market is still growing. It's insane. The pace they grow is just outrageous. So we need to get Europe and the US and the Americas back on track and keep growing, because otherwise the Chinese will overtake everything. Well, testing batteries is quite a big challenge when you test one battery. But the problem is not building one. The problem is building several. When you walk into a lab like this these days, if you walk into a large lab, you're going to see 100 to 200 test benches like that in a football field. It's like a whole stadium full of battery test benches. Managing that massive infrastructure and the data that comes from all of that and the power that you have to consume to test all these batteries is insanely complicated. The way we took to solve that is the same we took to solve HIL. It has to be software. Because if we try to do this by hardware, we will just kill ourselves. It's too complicated. Managing the power that can be used from here to here. So when you discharge this battery, you get the power from here, and you use it to charge the battery that is here, and you use to charge the battery that is there. So you don't need all the power from your grid. Is a massive software challenge that I tackled leveraging our platform. Okay? We built software from ground up to build single test benches to multi-test benches deployed around the globe. We have customers running test benches in Americas, Europe, and Asia, all interconnected at the top with the same lab operation management system, same dashboards. So the leadership of that company can see what's going on with their battery testing and development in a single dashboard in their phone or computer, because all data gets lumped into the same place and managed in the same way. That saves countless hours from the local teams to compile data, create reports, and put things together so their management can see what's going on and what. For that, we really need a bunch of different equipment. I mean, you know, and I can build measurement racks. That's typical. We had to go develop technology for power electronics. We built in-house battery cyclers, and we also acquired companies that build battery cyclers to increase our portfolio, right? And we really had to partner with a bunch of other suppliers that are provide interesting and important aspects for this solution, like chambers, chillers, infrastructure, really building the lab, like working with the companies that build the lab and make sure the lab is built in a way that can be used in the future. And NI has done it successfully, leveraging, as I said, technology developed in-house for power electronics with our battery cyclers developed in Europe. And with two companies we acquired, one in California named NHR, and one in Europe named Heisinger. That one is also an older acquisition from a company in Belgium that has been at NI for over 10 years now. So we develop a whole platform of power electronics to serve modules, packs, and energy storage systems with our own power electronics. But we also keep our software open. If you have power electronics in-house and you need to integrate that in our software, it's fine. If you have a preference for a different brand of power electronics for whatever reason, and you want to use that, our software is open. You're free to do that, which I can guarantee you is not the same when you go to other companies' software, because they want to lock you with their own hardware. We don't believe we have the best piece of hardware for everything, but we have the best platform for everything. That I guarantee, because it's open. It's developed by us, not by an IO. Okay. I'll leave you with one case study on the screen, and I'm open for questions. So, quick one. This is a massive OEM running labs in Europe. Over 1,500 channels of battery cell testing, a few dozen channels of module testing, and a few channels of pack testing. This is really a football field of test benches that have been built by one of the companies we acquired and now are built by NI everywhere in the world. Okay. Thanks for the time. If questions, I can take a few now. I'll be here the whole day. We can talk in the break, talk during lunch, and after as well. Thank you. Thank you, Pep.
Thank you very much, Leandro, and also Ricardo from National. If you have any questions, ¿alguna pregunta? ¿No? Pues en el chat, no sé si tenemos alguna, Guillermo. ¿Sí? ¿Está bien?